All right, so today we're going to look at lesson 5.3 in our pre-calc book, examples 5 and example 9. First of all, example 5, we're going to talk about compounding interest continuously. And when the number of periods that we compound interest increases, we get closer and closer to a continuous compounding interest, which is going to give us a value of called E that we're going to be using for that. And we figured that out when you did lesson or example number 4. Okay, so we're going to use the formula PERT for compounding interest continuously. And this right here, where in this case we have P is still our starting value, R is our interest rate as a decimal point, and T is time, but we're using E to do that, and which is our natural exponent. So here we go. We're going to find this problem. So we got A equals our amount we're going to get at the end. It was 4,000 times E raised to the power of 0.05 times 3. And it's as simple as just typing that in your calculator. So we'll do that. And I've got that right here, 4,000 times E raised to the power of 0.05 times 3. So that would be $4,647.34. So A is approximately $4,647.34. And so that's with compounding interest continuously. We're using the formula for PERT. All right. Now, we're going to look at radioactive decay. One of the things when you study in your science classes, maybe physics or chemistry, you talked about half-life. And so we have our function for finding a radioactive substance that remains after a given amount of time. So here P is once again our initial amount of substance. X equals 0 corresponds to the time when the radioactive decay began, usually when something dies. And H is the half-life of that substance. So we have this problem here, example 9. Says when a living organism dies, its carbon-14 decays exponentially. An archaeologist determines that the skeleton of a mastodon has lost 64% of its carbon-14. The half-life of carbon-14 is 5,730 years. Estimate how long ago the mastodon died. So when we fill out look at our function, we have A equals P, or f of x. So let me use f of x here. F of x equals P times 0.05 and x over in, this is where the half-life goes in, 5,734 years. In this problem it says determine, or an archaeologist determines that the skeleton of a mastodon has lost 64% of its carbon-14. Well, if it's lost 64%, there's only 36% remaining. So we're going to put 0.36 here for our ending value, and our starting value would be 100% or 1. So they started at 100%, it's now down to 36%. We want to know how long ago did this mastodon die. So we're going to try and find X. Well, here's the thing. Since this number, since our value here is, we're looking at half-life, so it takes 5,730 years for it to get to half of where it started. So if we are at 0.36, that's even less than half, so that means it's going to take even more years to get to that point. So my value of X is going to be greater than 5,730. So when I type this in my calculator to find the answer, right, so here I have it in my Y equals 0.5 raised to the power of X over 5,730. And we want to know when it equals 0.36. So when I go to my window, I'm going to choose a value of X max to be greater than 5,730 because it's going to take more years than that to get it. And so I put in 10,000. So when I graph it, we can see where the lines intersect. So we go to our intersect finder. So second trace, number 5. And we have our first curve, second curve, and our answer. So it's going to be approximately 8,000 445.6 years for our mastodon to be down to 0.36%. So here X is approximately 8,445.6 years.